Good morning everybody. Welcome to 5.2. Today we are going to be discussing transformations and which transformations lead to congruence and which ones do not. Keep in mind that a transformation is any change to a figure's size, location, or orientation. Three of them that we have spoken about already are a translation, which is thinking about sliding an object up, down, left, or right, a rotation, which you can think about spinning or rolling the object, and a reflection, where you can think about flipping it over a line of reflection. Something new we are going to talk about is a dilation, which is where you actually change the size of the figure by a scale factor, so you can think of either enlarging the image or reducing it or shrinking it. A rigid transformation is anything that preserves length, angle, measure, and area. So that means shape and size don't change. Another name for this rigid transformation, staying the same, is an isometry. Isometries, or rigid transformations, always produce congruent images, always, and translations, rotations, and reflections are always isometries. Dilation is not a rigid transformation or an isometry because it changes the size. So therefore, there's no way, if it is taking a figure and making it larger, that it is preserving size and shape, so there's no way that that is producing a congruent image. The first example we're going to look at is a translation or a slide. Keep in mind that you will always have the rule or the movement defined, and in this case, to our x values, we're going to subtract 3, and to our y values, we're going to add 2. So what we would do is we would take our 3 points. We now have a prime. We take our x value, which is 0, and we subtract 3 from that. So that means we now have negative 3. We take our y value, 0, we add 2, which means we now have positive 2. For b, we are going to apply the rule, apply the movement, and our x value is 2. When we subtract 3, we get negative 1. Our y value is 0, so when we add 2, we get positive 2. And likewise with c, we will determine c prime, so the image. 2 minus 3, again, is negative 1, and 3 plus 2 is 5. So what we want to do is we do want to plot these points. So a prime is negative 3, positive 2. B prime is negative 1, positive 2. And C prime is negative 1, positive 5. So if you look at this image, it looks like our original triangle, which is in blue, slid to the left and then up. And in fact, it went to the left 3 and up 2. Question is, are these triangles congruent? The answer is absolutely. This was a slide. We didn't change the size. The only thing we did was move the triangle to the left and up. If the images are congruent, and from our previous discussion on what an isometry is, this is absolutely an isometry as well. It preserved the size, shape, area, angle measures, everything like that. These are identical triangles. They're just simply slid to the left and up. An example of a rotation or a spin. The rule here is that we have our x and y values. First of all, we switch x and y, and then we negate the x. So, for a prime, we switch 0, 0. So we still have 0, 0, and then we negate the second number. Well, negative 0 is simply 0. B prime, first thing we do is we switch the order. So instead of 2, 0, we now have 0, 2. And we switch the sign on our second. So it was positive 2, it's now negative 2. And then for C prime, first thing we do is switch our x's and y's. So instead of 2, 3, we have 3, 2. And again, we put a negative in front of what is the second number. So it was positive 2, it's now negative 2. So let's plot these points. This should be a C prime. So we're going to have 0, 0. Then we're going to have 0, negative 2. And then C prime is over 3, down 2. So if we connect these dots, again, this is the same triangle, the exact same size and shape, It actually just looks like we grabbed the triangle right here in this corner and spun it down. We held this corner 0, 0, and we spin it down, so kind of like a roll or a spin there. So again, this is a rotation. So are these triangles congruent? Yes, absolutely. And is this an isometry? Absolutely. These are the exact same two triangles. It is just spun around. So if you picture it as a little piece of paper of a triangle that you just simply spun it on your paper, it's still the same size, still the same shape. So nothing changed about the size, shape, area, so that means it's an isometry, and they are congruent images. A reflection, this is a mirror type image. So if you are reflecting over a line. So let's take a look at what A prime is. The rule is that we leave X and Y in the same locations, but we simply are going to change the sign on our X values. So again, we have 0, 0. You can't really say negative 0. So A prime is simply 0, 0 as well. B prime, again, we negate the X. So instead of positive 2, 0, we have negative 2, 0. And C prime, 2, 3, we just negate the X, so it's negative 2 and 3. So the only change we're making is the negative in front of the X coordinate. So let's go ahead and plot these points. So again, we're at 0, 0, negative 2, 0, negative 2, 3. So if we connect these dots, so if we look, these are the same exact triangle, it's just that we flipped or mirrored or reflected our blue triangle, so our pre-image, over this y-axis here, and kind of picture folding this paper in half along the y-axis. So this would be the mark that you have on the other half of the paper. So it is reflected over our y-axis here. So are these triangles congruent? Absolutely. The base is 2, the height is 3. These are the exact same triangle. So yes, they're congruent. And again, yes, a reflection is an isometry. That means a rigid transformation. We didn't change size, we didn't change shape, we didn't change area, we did not change angle measures, we didn't change anything about it, except that we kind of copied it and reflected it over that y-axis. Taking a look at a dilation, remember, a dilation does change the size. It's either going to enlarge or shrink your image. So in this case, it's always multiplying your coordinates by a constant k that is positive. So what we're going to do is we're going to multiply by 2. So again, A prime, this means after we've applied the movement, we've applied the rule. 2 times 0 is 0, 2 times 0 is 0. B prime, 2 times 2 is 4, 2 times 0 is 0. And C prime, 2 times 2 is 4, 2 times 3 is 6. So these are our new points we want to plot. So 0, 0, 4, 0, and 4, 6. So 1, 2, 3, 4, 5, 6. So here is our C prime, and then again we're going to connect these points and look at the shape we have. So if you notice, our red triangle is much larger than our blue triangle. So the size definitely changed. The side lengths changed. The area definitely changed. We're looking at a much larger triangle. So these are absolutely not congruent images. You can tell by looking at it on our coordinate plane here that they're nowhere close to the same size. So then is this an isometry? Absolutely not. Our size changed. To be an isometry, you have to preserve side lengths, area, angle measures, everything. So basically, to be an isometry, you have to have congruent images, and we do not have congruent images here. So dilation is never an isometry, and it is never a rigid transformation. It is never going to produce congruent images, unless you just multiply everything by 1, in which case you would end up with the exact same image. You didn't change anything. Please let me know if you need any help.